Right, welcome back. MECH1340, Chapter 8, Programming Counters. Once again, this is going to be similar to what we did in Chapter 7. I'm going to kind of cruise through most of this part because it's Allen-Bradley, year 1 Allen-Bradley that we're going to do. You'll kind of be able to follow along. But for the most part, I want to get through the major concepts of counters here. I'll be able to talk about an up counter, down counter, and an up-down counter. Okay, and where they kind of relate in industry. Regardless of if we're doing Siemens, PLC, Mitsubishi, all those different things, okay, it's still the concept of understanding how a counter works. That's the same piece through all the different proprietary forms that we talk about. Okay, so let's talk about counter instructions, okay? If we talk about like an everyday like manual counter, right? You sit there and you can push a button and go click and click and click and it counts up. And then there's a master reset button, okay? So every time you'd like push a button, okay, an old school little counter in your hand, you'd push a button, right, it'd count up for you. And then you could clear a reset, okay? But electronic counters, okay, the way we use these is we can count up, count down, or we can combine and do an up-down counter. And like I said, it doesn't matter if we're talking Siemens, it doesn't matter if we're talking Allen-Bradley. The concept of what we're doing is the same. All right, in any form of manufacturing anywhere, okay, there is usually some form of a counter, right? You want to keep track of your product. You want to keep track of how much product you're doing per hour. All those different, sort of things. So how much is, going past a certain point, right? We go to Bridgestone, we see how many tires they're producing. They're keeping track of every single tire and counting. Same thing. We're counting cars as run the line at Nissan and all those sort of things. Okay, very, very similar to timers how we do instructions. So this one's coil based. Okay, so we write in the type of counter. So this is a CTU. So this is an up counter. All right, or count up. All right, we're going to give it a counter address, and we're going to go over the addressing when we do the Siemens labs, so that you understand what to put in for the addressing. Okay. We have a preset counter value, okay, and then we have the accumulated count. So the preset counter value is what we set it to. We want it to count to 5, or we want it to count to 10. The accumulated counter value is what it's at in the count, okay? And then we have a contactor in the front that initiates the count for each false to true. So for us, that's rising edge of the clock, okay? Rising edge of the clock. We talked about this in electrical class when we talked about signal analysis. So rising edge of the clock. We also talked about this in digital electronics. When we did flip-flops and things like this, we were always basing things on the rising edge of the clock. So when the clock went from 0 to 1 or false to true. So that's what's going to trigger our up counters here as we're doing it. So think of that as that's that manual button you're pushing, or we have a sensor. That every time that sensor goes off, right, we're counting what's going by. So very basic when we talk about a count up, and then when we want to get to that count, we want to be able to reset it. Okay, so we have a reset coil that actually resets. So this is counter reset, CTR. Okay, and for us to reset the counter, so say it's counter 0. All right, we need to reset counter 0. We have to have the same tag number for the reset coil as the up counter coil. Okay, then we just have a simple contactor that we have that resets the counter. So if we talk about the block formatted counter, and we'll probably use more of the block counter format in the Siemens, they do the same thing. All right, but we still have everything coming in. It's still going from off to on, or from on rising edge, or 0 to 1, or false to true. Still doing the same thing there. It's just going to be more block-like in our ladder program, but we still have the preset value. You can still see the accumulated value, and it's kind of how we tie in the count line and the reset line. Same kind of concept, as we go through it, but it just looks a little bit different in the ladder logic. It's more internal. The settings are than what we have to do and put on the quote piece. Okay? So if we talk about an up counter, every time we're using an up counter, it's going to increment by 1. Okay? A down counter is going to decrement or count down by 1 each time, okay, whatever the contactor is that's generalized. So we're counting up by 1 or we're counting it down by 1. Okay, getting up into the up counter a little bit more. Okay, so this is the block form here. So in the block form, okay, we have the count up and we have the opposite value, right? And then we have the counter tag number, the preset value, right? What we're counting to and what we've accumulated to so far. Okay, so here's what this looks like when we're in ladder logic. So on the outside, we have our hardwire diagram, and on the inside, you know, between the rails, we have the ladder logic. Okay, so we can see that push button 1 is going to be keeping track of our count. So every time we press push button 1, we're going to be counting up 1. So how much are we counting to? We can see the preset value on this counter is set to 7. So far we've accumulated nothing because we haven't hit the push button at all, but it's going to count to 7. Okay, the counter tag is 5.1. So then we have our count up, okay, high, and then our opposite, so our done bit. Okay, so what does that do? So we have counter 5.1, which is our DN. So when that's done, we're going to have a red light on that says that we are done counting. Okay, now if we have a green light going, that means we are in the process of counting. So we have a normally closed contactor on the done bit, let's call it, for the, you know, lack of a better term, I guess, but the done bit. So as long as the done bit is, you know, false, right, we're not done, we're going to have a green light on and we're going to be counting. Okay, then once the done bit is done, we've reached 7, all right, it'll close the contactor on rung 2, and the red light will go on and the green light will go off, and then it's going to sit there. All right, and then we will have to come in and reset it with push button 2. Push button 2 will reset the counter. Okay, and what it's going to reset, okay, it's not going to reset the preset value, it's going to reset the accumulated value back down to 0 so that we can keep counting. All right, because, you know, even with this counter, all right, I can keep pressing you know, the push button and it'll accumulate greater than the preset, but it's not going to do anything then, all right, because we've reached the preset value. Okay, so kind of here's what's going on. Okay, if we just take a look at a timing diagram here. So on rung 1, okay, I'm going to flip back so you can see rung 1, that's the push button, right, where we're hitting the count. So every time you see the clock go from 0 to 1 or from false to true, okay, we should be getting a count. Look at the very bottom of the timing diagram. That's where the count is. That's the accumulated value. So you can see that every time the clock goes from 0 to 1 or from false to true, we are incrementing our count. So you can see where it's stepping up from 1 to 2 to 3 to 4 to 5 to 6 and then to 7. Okay, and we can monitor the other rungs. So rung 2, okay, that's telling us when we're done. We can see we do not get done until what? Rung 7. Okay, once we've counted up to 7, I'm not rung 7, but on rung 2, we can see that we are finally going to get an output signal and turn the red light on when we've reached our count of 7. And notice rung 3, okay, rung 3 is telling us that that's a green light. We are still counting. Okay, so rung 3 on the timing diagram is going to stay on until we get to the count of 7. When we get to the count of 7, rung 3 is going to go to 0. Then, if you look at rung 4, that's the reset button. Once we've reached our count and stayed at that count of 7, okay, we hit the reset. What happens on the reset value? Okay, our accumulated value is going to drop down to 0. Rung 2 is going to go to 0 because that means we're going to be counting. And rung 3 will have the green light back on. And then we'll be waiting for the push button to be pressed again. And we would start the process all over. Okay? And this is what it would look like in your Allen-Bradley software, okay, as it simulates and goes through. Okay, so I'm going to kind of skip through the Allen-Bradley addressing. You can pause these and take a look at it because, like I said, we're going to be doing our Siemens addressing. But we can still look at the table, and you'll be doing this stuff in your labs when we get to the Siemens stuff. But, you know, essentially, count up isn't going to be too bad. We're just going to toggle some switches on your PLC simulator that's going to simulate your push button, or how many simulate a count for us to keep track of things. Okay. So if we take a look at the nomenclature, this is for the RS logic, okay, Allen-Bradley stuff, but it still holds true with Siemens. So we have the CTU, the count up, and the CTD, the count down. And then Allen-Bradley also has this high speed counter, so it's counting high speed pulses as well. Okay, so in this case, and why we want to keep track of pulses? Well, when we pulse out for like a motor to move forward or something like that. Okay, so in this case, we have a counter program that's used to stop a motor from running after 10 operations. So a motor's going to run 10 times and then be done. And essentially, we're going to run that motor off the counter, and the counter is going to run. So when the motor kicks on, okay, notice that there's a contactor in rung 2, say labeled motor. That every time that holds true, all right, that contact closed, we're going to get a count up. Okay, when it stops, okay, when we reach 10, notice the line in rung 1 that has the counter 5. Okay, the DN, so when the DN, the done bit, right, becomes true, all right, that contactor is going to open and the motor won't be able to run until we restart the counter or reset the counter. Okay, so just looking at those different things, if we need to cascade some counters up to do a couple different tasks at the same time, we can use, 3 up counters, and we cascade them just like we did in the timer lecture. Okay, so we also have a one-shot or transitional contact, and that's what we're using sometimes, that will automatically clear or reset a counter. Okay, so we can use it so it's built into our ladder logic. So if we have it stay on for a scan and then goes off, or it stays on until a trigger goes off and then comes on again. So we can have something that sets off that internal relay coil that actually operates the reset. Okay, so we can do that. So if you take a look at it, notice even though the internal relay coil, and that's our memory coil in Siemens. Okay, remember, that's just storing data. That's not actually like sending out to a field device. Okay, but we can have a memory coil there. That's, even though it's in rung 2, we can use it in rung 1. All right, so that when that becomes false, it'll open up. Okay, and it will reset for us. Okay, so that's what a transitional contact is. Essentially, we just use a memory coil to kind of go in between and help reset our counter, things like that. Okay, so this is just one-shot stuff here on Allen-Bradley. Like I said, I'm going to cruise through this because we're going to be doing all this stuff in our Siemens labs and things like that. So we will get through this part rather quickly. Okay, you can use it to monitor an alarm. All right, this here is a combination of doing counters with timers. Okay, so we can count how many times something has gone on fault or things like that, how many times a particular alarm's gone off for certain things, and we know that helps us troubleshoot or do those sort of things as well. So we can have these built into the program that helps us monitor what's going on. So if we are consistently getting some sort of fault, like daily or hourly or those sort of things, we can check on a count. Well, how many times has this happened? And it really helps us step back and troubleshoot as we go through fixing our line or our system. Alright, so let's go ahead and take a look at down counters right now. And I just want, setting up the down counter is the same as setting up the up counter. So I don't want to dwell too much on what we're doing with the down counter, okay? Other than now, if we start at 10, we're going to count down to 1, okay? So we're counting down instead of up. That's really, the basics on it. So if we look at the timing diagram like we did before, okay, it's still focused on, counting down. So let's take a look we're halfway through the timing diagram, okay? So if we look at counting, skip the counting up and let's look at the count down. See where it goes 1, 2, 3, 4, okay? It's counting down there though. So in this case, we've used an up-down counter. So for us to count up, we can see that on the rising edge of the clock, we're counting up, we've gone up to 6, and then we're going to count down 5, 4, 3, 2, 1, okay, when the count down clock clicks. Okay, so this is a counter that can count up and count down as we're going through. Okay, so if we take a look at this sensor here, this is combining a count up with a count down counter. Okay, so we can see, it's going to go up and it's going to go down. Now, here's the very important part here. Notice they have the same tag. Okay, even though we have a count up counter in rung 1 and we have a count down counter in rung 2, they carry the same counter tag. So that's how it's going to know. Alright, you'll see the accumulated value. As it counts up, alright, you hit the enter switch a whole bunch of times, you're going to see that accumulated count go up. But then as you hit the exit switch, that accumulated count's going to go down. Okay, so we're going to do some up-down counters as well in our Siemens programming. Okay, but why would we want to use this? Well, this is, a parking garage. So we have to know, if the parking lot is full. We don't want more people coming in if, the parking lot's full, because then we're just going to get traffic backed up because everybody's going to be doing, circles to find a parking space. All right. We use a lot of automated systems like this. If you go to Las Vegas, a lot of the casinos there have a counter and also an overhead indicator. So in the parking lots in the garage, there's a little light that hangs down in green. They're green and red. If there's a car parked there, the light's red. If there's a green light there, okay, that means it's free. It's an open space. But it also keeps tally of the cars that go in and out, and it keeps track of its green and red so that it knows, all right, I have this many open parking spaces. So just kind of cool little concept of where you can, use an up-down counter. We're going to simulate this stuff with our Siemens simulation stuff, so we'll get into a little bit more of that. But I just kind of want you to understand the basics of, an up-down counter, where we can apply it, and what good it's doing for us. Okay, we can monitor systems, in a process with it. So that's really what we use them for. Okay, we're monitoring what's going on in separate programs. All right, lastly, cascading counters. Okay, just like we have with cascading timers. Okay, it might have us calculate events that occur when we exceed the maximum number allowable per counter instruction. So we can do that by cascading a couple counters here. Alright, so that'll help us get above and beyond the maximum count in a specific program. Alright, because counters might be set to only count a certain amount. So we want to be able to keep going through our operation, keep counting to go above and beyond our maximum count that we have in a program. Okay, so for when we have really, really large count values and things like that. So you can cascade the two counters as we go through. Okay, we can just look at, this is the example of a 24-hour clock program. It does the same kind of concept here. Okay, so I'll let you guys take a look at this because we're going to do some programming through this. But these are, like I said, they're all Allen-Bradley examples, so I don't want to spend a ton of time on them. So we're going to be, programming everything on our Siemens for the most part. Okay, so incremental encoder counter applications. So we use, some sort of things on this, like on servos and things like that. So we use an encoder disk, on it. So we want to count, how many times it's rotated around and in which direction. That helps translate into our X, Y, Z. If we're using an example here where we're cutting wood to a specific length, okay, we want to make sure that we're counting, how many times maybe the motor's turned in order to know that since the motor turns this many times, it actually calculates to this much distance on the conveyor belt and those sort of things, so we know when to cut. So, just different, devices that help you run a machine. That's really,
it kind of varies per machine what the task is and why you want to apply them, and if a counter makes sense to run that way. Okay, and lastly, we can talk about combining motors or counters, and I'm sorry, not motors, but counters and delays on timers and things like that. So we got to make sure that we can keep up with counts and do counts accurately, and we want to delay things and use different sensors to combine with the counts and times. So we want to make sure everything's properly aligned when we're dropping something, as we're having two conveyors working together, and we're dropping something from one conveyor onto another conveyor. Timing is everything, but we still want to not only time it, we want to count it and make sure everything is going as well. Concepts, you're going to read about these in your textbook for the most part, but we can use it to keep track of product flow rate and those sort of things, where we have timers and counters. So we know that if we're keeping track of time, we know how many products we've counted in that certain amount of time, right? Production speed means everything. If we're in a bottling plant, right, we want to make sure we're counting how many cans of Coke are coming through the system at a certain time. How many cases are we actually able to pack at a certain time? How many tires are coming off the line at Bridgestone? How many cars are coming off the line at Nissan? Okay, there's not a person standing there at the end counting everything, but they know from time, from start to finish, over this certain amount of time, this many cars are coming off the line, and doing that sort of thing. So just important to kind of combine all of those. And we're going to be doing something like that, like I said, in lab. Program this using our Siemens TIA portal. Okay, so just wanted you to be exposed to some of the Allen-Bradley stuff. Like I said, we're only doing the 1 or 2 Allen-Bradley labs. Everything else is going to be Siemens. But the purpose of this lab was for you to understand what a count up counter does, what a count down counter does, and how a count up and down counter kind of works, and how we can kind of use counters intermittently with timers and things like that. But I'm gonna do a couple other lectures on counters using our Siemens stuff, so you'll be able to watch those as well. But really the whole point is count up counter every time the clock changes from 0 to 1 or from false to true. We're keeping a count up and we're incrementing by 1. Or a count down counter is still going from false to true, but we're counting down now, so we're decrementing by 1. Alright, we still have preset values. We can monitor the accumulated values as we're counting up and down. And then of course we can combine up and down counters to be able to keep track of that as well. As usual, guys, email me with any questions. Let me know if you need to Zoom or Team Meet or anything along those lines. Else, guys, have a great day. I will see you in class.